So remember when we talked about, welcome, blah, 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 or skip that part. Remember when we talked about one-to-one functions, we said a one-to-one function is if it passes the horizontal line test, right? If there's a unique input for every output, as opposed to the other way around. So if functions are one-to-one, their insides have to be equal. So the square root of x, remember what the square root of x looks like? Kind of has that shape. This is a one-to-one function, passes the horizontal line test. So if this happens, then the insides have to be the same because it's a one-to-one function. Whereas if I look at the parabola, so what does a parabola look like? Parabola looks like this. Parabola is not a one-to-one function. So maybe x is the same as y, but maybe it's not. So who knows, right? We could have something like 2 squared equals 2 squared, but I don't know. Maybe 2 squared, well, that's also equal to negative 2 squared, but 2 and negative 2 are not the same, right? So if we have a one-to-one function, it makes it easier to solve equations, because if the function is being done on both sides, we can just get rid of it, all right? And that's how we're going to start today, because exponential functions and logarithmic functions, these are both one-to-one functions as well. Exponentials and logarithms are one-to-one, so we're going to use some fancy properties to help us solve some of these equations. We're going to start with example 1, where we always start. Solve the following. Part A, 2 to the x equals 8. So we've already done this problem. You already know how to solve this problem. You may or may not remember how, but you have in the past. The answer is 3, because 2 cubed is going to equal 8. All right, but there's another way of looking about this, right? We can write 8 as 2 cubed. Now this is 2 functions, an exponential function over here, an exponential function over here. And because they're one-to-one, the exponents have to be equal. We're going to get that x is equal to 3. All right. And that's the summary of this entire video. So part B is going to be 2 to the 2x plus 5 equals 4. Again, if we get exponentials on each side, their exponents have to be the same thing. Well, the right-hand side's 4, not 2. Well, let's make it 2, right? The right-hand side is 2 squared. The left-hand side is 2 to the 2x plus 5. Now we have exponential functions on both sides, so their insides, their exponents, have to be the same. All right, so we get that 2x plus 5 is equal to 2. And whoa, this is no longer an exponential equation. This is a linear equation, and we can solve this accordingly. So we're going to get that 2x is equal to, subtract 5 from both sides, you're going to get negative 3. Divide both sides by 2, and you're going to, x is negative 3/2. When you're solving a problem like this, don't just trust, don't believe in yourself, okay? I'm going to be anti-Disney today. Don't believe in yourself. Check your work. Let's see if we're right. Is 2 raised to the 2 times negative 3/2 plus 5, is that equal to 4? So let's simplify. This is going to be 2 raised to the exponent 2 times negative 3/2. The 2's cancel. We're left with negative 3 plus 5. Well, negative 3 plus 5 is 2, and 2 squared is 4, exactly what we wanted. Okay? So we're checking our answers. Very simple to do. And it can save you a lot of pain. If you just make the smallest algebra mistake, you can find it over here. Which is one of the nice things about math. So there's a lot of ways that you can check, is my answer actually right? All right, let's do part C. If part B wasn't fun enough. Part C and part D, we really just really throw the bathtub at you. That's mixing metaphors. Never mind. I'm throwing a bathtub today. 3 raised to the 2x plus 1 times 3 to the x is equal to 81. So now this is not two exponentials equaling each other at all, but we can make it. Let's make the left-hand side a single exponential function. Let's make the right-hand side 3 raised to some power. So the right-hand side, we'll start with that one. That's easier. 3 to the first power is 3. 3 squared is 9. 3 cubed is 27. You can keep on going. You're going to get 3 to the fourth power is equal to 81. On the left-hand side, we want to combine these. We have two exponential functions multiplied by each other. That's going to be adding their exponents. So if we add the exponents, we get 3 raised to the... Well, that's actually right, but I didn't want to do this step. 3 raised to the 2x plus 1 plus x, right? Just add those exponents and then simplify. 3 to the 3x plus 1. Which is, I wrote the 3, but I didn't want to. All right. 2x plus x is 3x. And now, since we have two exponential functions equal to each other, their insides must be the same. We get 3x plus 1 has to equal 4. Subtract 1. 3x has to equal 3. Divide by 3. X should equal 1. And because you're really, really excited to see, am I right? And you just can't wait for me to grade your exam. So you're going to plug in 1 and check our answer. So we're going to see, is 3 raised to the 2 times 1 plus 1 times 3 to the first power, we're just plugging in 1 everywhere, is that equal to 81? Well, if we simplify, this becomes 2 times 1 plus 1. That's 3. Times another 3. 3 cubed is 27 times 3. Oh, it's 81. Just like we wanted. And now you can go to bed happy, knowing that you solved example 1, part C, correctly. We wanted that left-hand side equal the right-hand side. We looked at the left-hand side. It equals the right. Great. All right, last problem for this video. This one's a spicy one, just like the tapatio and the cake we were baking last week. All right, if you remember, if you remember back that long. We got part D. 1 over 64 to the 2n power times 4 equals 2 to the 6. You look at this and you go, whoa, Jason, that's a lot of stuff going on. Just do it step by step. We want to write this as an exponential equal to another exponential. The right-hand side's already done for us. 2 to the 6th power. We just need to write the left-hand side as 2 to some power. Okay? So, there's a couple steps to this. Let's look over this. This is not a 2. 64, though, that's 2 to the, 2 to the first power is 2, 2 squared is 4, 2 cubed is 8, times another 2 is 16, times another 2 is 32, all right, 64. So that's 2 to the first power, second power, third power, fourth power, fifth power, sixth power. 2 to the 6th power is 64. But we don't have 64. Let's do it in steps. This becomes 1 divided by 2 to the 6th. We're a little closer. The 2n stays the same. The 4, we can definitely deal with. 4 is 2 squared. All right, we made progress. It looks a little bit more like 2 raised to some exponent. All right, so now we have to deal with that fraction, right? Fraction means negative exponent. This becomes 2 to the negative 6th power raised to the 2n times 2 squared equals 2 to the 6th. Only thing that changed here is we wrote this fraction with a negative exponent. Negative exponent means fraction, means reciprocal. And now we have an exponential raised to an exponent. We multiply those exponents. Negative 6 times 2n is negative 12n. And now we're very close. Two exponentials multiplied by each other with the same base. Let's add those exponents. 2 to the negative 12n plus that 2 equals 2 to the 6th. And finally, we've got two exponential functions equal to each other, which means since they're 1 to 1, Let's equate those exponentials. Sorry, let's equate the exponents. So negative 12n plus 2 is equal to positive 6. Solve this equation. Subtract 2 to get 4. Divide by negative 12 to get negative 4/12, which simplifies to negative 1/3. And this should be our answer. But don't take my word for it. Okay? Don't take my word for it. Let's check our answer, make sure we're right. So this one especially, let's check our answer with a calculator, right? So is 1 divided by 64 raised to the 2 times negative 1/3 times 4, is that equal to 2 to the 6th power? All right, we're going to use a calculator. Google, help us. We have 1 over 64 raised to the 2 times negative 1/3 times 4. So Google says that's equal to 64. What about the right-hand side? 2 to the 6th power. Oh, that's also equal to 64. Neat. We're good. Boom. All right, and that is one way to solve exponential equations. Let's say you went through this whole video and said, Jason, that's 11 minutes of crap I don't want to do. Well, there's an alternate way to do some of these that we'll talk about in the next video. And that alternate way can be used for any exponential equation, okay? But this can be a simpler method for a lot of times.